Today, Rachel and I are going to be going over Git basics. We're going to be walking you guys through a pretty conceptual demo, just using some little images that are on the slides, but then we're going to actually take a dive into something a little bit more real. I'm going to share my screen, my terminal, my VS Code, and we're going to practice, just how to clone, how to edit code, and things like that, and of course, how to push. So yeah, without further ado, let's get started with some quick introductions. Or rather announcements, sorry about that. So first and foremost, we have our in-person project kickoff on September 11th. That is going to be on a Monday, I believe. And yeah, this is going to be the time where you guys will meet your group mates for the entire semester, your project managers, and you guys are just going to get to introduce each other, talk about some project ideas. We are going to have pizza there, so dinner is provided. And it's usually a really fun event, and you meet a lot of people. So please mark your calendars now. This is a mandatory event, and this is also in person. So please plan to be there. Also, we'd like to remind you guys to rename yourselves in the Discord server to your preferred name, followed by your net ID in parentheses. If you guys, we announced this during lecture 0, but by September 8th, we're going to be removing all members of the Discord server who don't have their nicknames in this format. So, I'm sure everybody on this call already has it done, but just as a quick reminder, please do that. And last but not least, today, September 1st, is the university's course ad deadline. So starting, tomorrow, September 2nd, you are not able to register for any courses. What that means is that we need you guys to register for CS124 honors by tonight if you are planning on taking the course. If you are not a James Scholar and you filled out the enrollment confirmation form, you're in the server, you're coming to our lectures, you're doing your Prairie Learn, but you haven't actually registered on self-service, then you're not going to get a grade in the course, unfortunately. We need to make sure you guys have registered properly. If you're a little bit unsure and it's like 11:50 at night, just register for the course. The university drop deadline is later on in the semester, so no harm, no foul if you do decide to drop, but it's a lot better that you register properly and then decide to drop later than you don't register, you complete a semester-long project, and then you don't get any credit for it. We've gone over these a bunch of times, but just to kind of quickly break it down, fill out the enrollment confirmation form, regardless of whether or not you're a James Scholar. You need to do this. This is what we use to match you guys into groups, so please fill this out as soon as you can. For non-James Scholars, register on self-service. That's CS199, section 124. CRM is 67084. And for James Scholars, please fill out your HCLA for 124, not 199, 124. Just on your HCLA, indicate that it's for CS124. And if you are a James Scholar, you should not be registering on self-service. Yeah, without further ado, I'm going to kick it off to Rachel to walk you guys through Git.
Okay, so how many of you guys are familiar with Git? Just do like a thumbs up reaction or something. I just want to get a gauge. Okay, so like a handful of you guys. So yeah, for those of you who aren't familiar with Git, Git is a version control system. So basically what it does is it tracks changes to your project files, allows for very easy and secure collaboration with other developers, and it also allows you to recover files that you may have like deleted, whether accidentally or you just want to go back and look at those. And there's just a lot of things. So it's essentially just managing the different versions that your code goes through. And so you'll use Git for other classes in, CS, and also to share your own projects, as well as during internships and like working in the industry. Yeah, so how does Git actually work? To give a very brief conceptual overview, we're going to take a look at John, some imaginary person named John. And so let's say that he has written some really cool code. So he has it stored in his computer, in that folder that you can see on there. And so he wants to share it with his friends, right? So how should he do that? He's not going to just give him his computer, or what if they are not right next to each other? How can you share your code remotely? So the first thing you're going to want to do is to create an empty GitHub repository. And so GitHub is not the same as Git, but it does utilize Git. And so we will be using GitHub a lot during this class. And how do we get the code into the repo? So you can see that there is a GitHub repository. So that's going to be the remote repository. And we also have John's repository on his actual computer. Okay, so in order to get the code from John's repository to the remote GitHub repository, you're going to want to push your code. And so that's actually a Git command called push. And
Sorry, I think my computer might be lagging a little bit. There we go.
Yeah, I think it's lagging. Okay, yeah. And then so now John's code is stored in the GitHub repository after he pushed it. So how does Mary get John's code now? So Mary's computer doesn't have John's code on it, right? But John's code is stored now on the GitHub repository. So Mary needs to clone the repository, and then that way she can get it onto her computer. And she does this by cloning that GitHub repository that is remote. And so now it's on her computer. And then so how does this work with like collaboration? Let's say John and Mary both want to contribute to that same repository. You can't actually see the code when you're working on the two separate computers, right? So whatever changes John makes locally on his computer, Mary will not get on her computer. And so let's say that Mary wants to suggest some changes to John's code. How can she do this without directly overwriting the repository? So this is where we introduce Git branches. Essentially, you can create a branch and then work off of that. And so Mary creates a new branch called Mary Suggestions. So this is where she's going to, put her code suggestions for John's code. And for now, the code is still the same, but it is now on a different branch. So Mary writes her new code. She's on a different branch now. You can see that it is blue. And then John's branch is red. And then so she pushes her code. Remember, pushing is when you take your local changes and put it to the remote repository. And then so she pushes her code to the Mary Suggestions branch. And then now John will look over the changes. He can see if he likes them or not. And then he can do something called merging, which is essentially taking Mary's changes and applying them onto the main branch, which is what John was working on. And now John can pull from the repository and have the updated code on his local machine. So it kind of saw how it went through like multiple steps of John creating his code locally, pushing it to the remote repository, and then Mary pulling from the remote repository onto her local computer. Then she created a new branch to create changes so she didn't overwrite the changes automatically. Then she pushed that branch and her changes into the remote repository. So now John took a look at that, he liked it, and now he can merge it onto the original branch. Okay, so yeah, we're gonna take a look at pushing. So how does pushing to a Git repository actually work? So we're gonna take a look. There's generally 3 stages to this. So when you're on your local computer, so on John's computer, for example, you have something called a working directory. So that is where you are going to be making all of your changes, writing all of your code. And then you can use the git add operation to add your changes or save your changes to the staging directory. This is where your work is saved, but you can still continue working on things, making changes. And then lastly, you can use git commit to commit and save those changes to your local Git repository. And then once you're done with all of that, you're ready to push to the remote repository. That's when you use the git push operation. So now your teammates can also access your code. Okay, so these are the commands that you use. So git add moves your code from your working directory to the staging area. Git commit, the -m flag is just for the message, and then you write your commit message. A commit is basically just a snapshot of your repository at a certain point in time. And so using the commit readies your code into the staging area so that you can push it to the Git repository. And then finally git push. This is the format of the git push command. And so this basically just pushes your code to the branch specified with branch name. Okay, and yeah, so I'm just going to talk a little bit about git pulling. So again, if you guys have any questions, feel free to ask. But basically, there's only one command for this. You use git pull, and then that is when you take the remote changes and you apply them to your local computer. Or you take it from the remote repository so that you can view them in your local repository. All right, so I'm going to hand it over to Drew now for the demo.
Awesome. I know we kind of ended on the thank you slide, but that is not the end of today's lecture. I'm going to quickly be going over a kind of demo so you guys can understand a little bit better about how everything Rachel just broke down actually applies when you guys are going to be working on your project. So I think there are a few questions in chat. We'll probably be going over it after the end of the lecture. So yeah, feel free to put your questions in chat, but we'll be getting to those. Rachel may message in chat now, or we may just address those at the end. But yeah, I'm going to keep the slideshow open, but for now, you guys can still see my screen, yeah? I'm now on github.com. Rachel, can you see my screen? Okay, awesome. I'm gonna assume the rest of y'all can as well. So I kind of created this dummy repository right before the lecture, 124 honors demo, really basic. It's just my initial commit. Created that on github.com itself, nothing to do with my computer. So this is now firmly just present only on github.com. I cannot find it on my local computer. I don't think anybody's cloned it yet, so nobody else's local computer has it. And all it has is just this readme.md that says 124 honors demo in it. So the first thing you guys want to do is to clone the repository. Now, for the project itself, your project managers are going to be creating a repository for you and adding you guys as members. To add somebody as a member, you can go to settings and then collaborators. And then I'm not going to do it now because, I have to sign in and all of that stuff. But essentially, you can add the people who you'd like to have edit access to your repository as collaborators. So right now, since it's a private repository and I have no collaborators, nobody else would be able to edit. But, for the purpose of this demo, let's say I've added a bunch of people who I'm working on this project with. So the first thing that all of us are going to want to do is to clone this repository. So you're going to hit the green code button and you're going to see this HTTPS link. So you can copy that. And then what you're going to want to do is, let's see, I'm going to share my whole desktop so you guys can just see everything as I'm doing it. All right, so as y'all can see, I'm now in my CS124 honors folder. So the first thing I'm going to do is git clone, and then I'm going to paste that HTTPS link that I got from github.com. Now, when I execute that, you'll see these lovely messages cloning into 124 honors demo and all that. And so now if I commit or if I use my ls command, ls basically shows you everything that's in that folder. I see 124 honors demo, which is the name of my Git repository. So I know that this was successful. I've now successfully cloned onto my machine. So essentially what that represents is this right here. So you can say I was Mary's computer, I had nothing, and then I executed the git clone command, and now all of a sudden I have the repository on my computer. So what does this mean, right? This is great, everything's here, but let's take a look at my VS Code. So now I can see, sorry, just because I'd renamed that. So let me open my folder again. All right, so it's going to be CS124 honors, right? And now I have my 124 honors demo GitHub repository. So as you can see, I have my readme.md in here. It's the only thing in the repository online, and it's the only thing in the repository on my local machine. So let's say, I want to make some changes, right? I've decided, okay, I don't like this readme.md. I want to add something that says, hi, my name is Drew, and I'm one of the course leads for CS 124 honors in fall 2023. Great, right? I've saved it. This is now on my local machine. If I open this up on my local machine, this is what I see, right? But if I go to github.com, I refresh, it's still just 124 honors demo. I don't see any of the updates. And that's because I now have all of these changes on my local machine. I haven't yet pushed those, as Rachel was breaking down, to the GitHub repository. So how do I do that, right? And as we mentioned before, we have all of them kind of listed here. This is the pushing overview. These are the commands that you're going to want to use to push. So I'm going to come back to my terminal and I'm going to say, okay, let's just double check and make sure that my changes are saved, right? So I'm going to cd into 124 honors demo. I see my readme and I'm just going to cat readme.md. Cat, that's just a command that you can use to view a file. It just kind of spits out the file in like a raw txt format in your terminal itself. There's a bunch. There's Vim for Mac. There's Nano as well, which you can use to edit, but Cat just kind of spits it out. And that's all I need, right? I see, okay, on my local computer, I have the second line of my introduction, and I'm trying to get that to my remote GitHub repository. So I'm going to do git add dot. And just as a quick overview, this dot right here, that basically means all my files. So let's say I added 5 files, and if I did git add dot, it would basically get all 5 files ready to be staged and then ready to be pushed. But I could alternatively just do git add readme.md. And then the other 4 files that I was working on would basically exist only on my local computer, and only readme.md would be ready to go to push. So now I'm going to write my commit message. I'm going to say updated readme.md. You usually want to have at least relatively, relevant and meaningful commit messages. It kind of helps when you're going through the version history. If you're looking through if somebody accidentally overwrites something or accidentally deletes something, you can go through your commits and you can say, okay, I want to get back to when, Mary updated readme.md. Okay, let me go through the commit messages and I can very easily find that commit. So do your best to use some meaningful commit messages. And as you can see here, it says updated readme.md. One file was changed, and it tells you the amount of insertions and deletions. The numbers can be a little bit misleading since I did change one line, but it essentially means 2 new lines were inserted and 1 was deleted. So the one that was deleted was essentially this line, and then the 2 new ones that were added are these 2. It's a little bit counterintuitive since this first line is the same, but that's essentially all that means. So now I'm going to do git push origin master. Let's see. Sorry. What is my, it's called main. So main is the name of my branch. Essentially what this is telling me is, okay, there's no branch named master. So I'm going to git push origin main. And awesome. Okay, so now when I go back to github.com, I should be able to see my introduction there. And what do you know? Perfect. Right? I've successfully taken code that I wrote locally on my machine, and I've now pushed that to github.com. So that's a great overview of some of the basics, right? But let's get into some stuff that's actually going to be applicable to you as well. Obviously, this will be, but I'm going to talk about branches a little bit. So let's say that I wrote this now, and Rachel takes a look at my code, right? She's one of my collaborators, and she says, I also want to add an introduction for myself, but I don't want to directly overwrite the repository because people are changing it and things like that. So let's say Rachel has gone through and she's decided to change it. For the sake of this demo, and since I'm the only one sharing my screen, I'm just going to edit this locally on github.com. But, for the sake of argument, let's say Rachel cloned the repository, pulled the code, did exactly what I did, edited it, and then pushed back to the repo. So let's say now Rachel said, hi, my name is Rachel, and I'm the other course lead. And this is something you can do on github.com. You can actually change your files. It's a bit of a pain if it's not a TXT file because nobody wants to write code like that. But yeah, let's say that now Rachel has officially pushed this change and now it exists on github.com. Hi, my name is Rachel, right? But if I go back to my VS Code, what do I see? I just see, hi, my name is Dhruv. So now what I need to do to get her changes is to pull. And like Rachel mentioned before, it's a very simple thing. It's just one command of git pull. And now all of a sudden you can see one file was changed, readme.md. If I go back here, boom, I can see it in my VS Code. Hi, my name is Rachel. All right, so sorry. So now let's say I want to edit on a branch, right? So I'm going to say, okay, I want to create my own branch so that I can now kind of mess around, make my own changes without it actually automatically being reflected. Git is a powerful tool because it can save your work. So, let's say you've written 1,000 lines of code, pushed it to Git, and your computer gets, bricked in the rain or something like that, then all of your code is still saved on Git. But at the same time, right, you might not always want to push to main. If you're in the middle of working on something, you don't want to push unfinished code into the main branch because that's what everybody sees online. When you do git pull, that's what gets pulled to your repository. So obviously you're doing your best to make sure, okay, I'm saving my code on Git, but I'm doing it in a space that's safe to keep unfinished code. So how you do that is branching, right? As Rachel kind of broke down in her conceptual version, Mary said, okay, I want to make some suggestions, but I want John to look over them before it's finalized. So I'm going to create a new branch. A helpful command is git branch -l, and that lists all of the branches in the repository. As you can see, we just have one main. So I'm going to make a new branch, git branch, and I'm just going to name it my net ID. This can be really helpful. This is usually what we do in 124 honors. Each one of y'all will have your own branch on the repository so that you can push, your unfinished code, whatever you need to the repository, and just to save your code. And then once it's ready, you bring it back and merge it into main. All right, awesome. So I have through KS2 as a branch, but I'm still on main, right? So if I make any code adjustments and I push, it's going to be on main. So how do I switch to through KS2? That is the git checkout command. So if I do git checkout through KS2, you can see here, switch to branch. And now if I run that same -l command again, you'll see that I am on the through KS2 branch. So let's do a quick demo, right? Let's say now I update the readme.md again. Rachel pushed something else to the main. And it says, okay, testing to see this updated. All right, awesome. So Rachel has now updated that, and her intro says testing to see if it's updated. But that was pushed to the main branch. As you can see here, I'm on the main branch, and this is there. But if I come over to my terminal and I git pull, right, there's really nothing else, right? Because now you can see my main was updated, but I haven't merged anything. So if I come over here, there's no actual changes because I'm on the through KS2 branch. If I was on the main branch and I pulled, I would be able to see the testing to see if it's updated. But because I'm on my branch and Rachel's updates were made in the main branch, I can't see them. So a good practice is always making sure that you pull from the main branch before starting a new branch. Because let's say right now I created my new branch off of main before doing git pull, I would then miss this update. So I wouldn't have the most up-to-date code. But let's do a quick run through, right? Let's say, okay, I want to update my code and I'm going to say testing this line. Okay, all of a sudden I've updated my readme.md again. I'm going to come over here and I'm going to do git add, same thing we did before, updated through readme. And then I'm going to do git push origin through KS2. As a quick word, through KS2 is the name of the branch. As we saw before, git push origin main is what allows us to push to the main branch. And then git push is that actual, letting your computer know, okay, I want to execute a push right now. But you might be asking, okay, what is this origin, right? What does that mean? Origin is what's known as a remote in Git. There's nothing special about the word origin. This is just kind of the industry standard. It's the default that comes when you create a repository, but this is essentially a remote. What origin stands for is basically that HTTPS link that we had all the way back at the start when we cloned. So it's basically just a shorthand. Instead of constantly needing to put the HTTPS link, which would be kind of a hassle, we just use origin as a shorthand remote to let us know, okay, I want to git push into the origin of this repository onto the through KS2 branch. Okay, perfect. So as you can see, that was a success. And now you can see, if I click my branches here, if I view all branches, I have my through KS2 branch. So if I click on this, all of a sudden, Rachel's changes, right? It no longer says testing to see if it's updated, but my changes are here, testing this line. So this is hopefully giving you guys a good understanding of how exactly it works when I have my own branch and we have our main branch, and how I want to develop on my own branch and then eventually merge it in once I'm done. So obviously, this is not going to be my final product. I'm going to keep updating, but let's say, okay, now I'm ready for the world to see this. Awesome. I'm done. I finished my code. It's been saved incrementally in my Git repository, just to make sure I don't lose any of it. But let's say I'm ready to go. So I'm going to run the same command again. Branch finalized. I'm going to do git push origin through KS2. All right, awesome. So I come over here back to github.com. Now I'm ready for the world to see this. Usually you want to use github.com when you're merging branches. It just makes it a lot easier to visualize, but there are also really powerful tools, in VS Code, and you can also do it through your terminal as well. So you'll usually see this very helpful message. The branch through KS2 had recent pushes less than a minute ago. So what I'm going to do is I'm going to create a pull request. This is what you guys are going to be doing as you develop your code. So once you have your branch set up and you're good to go, you're going to create a pull request. And what the pull request is basically you letting the repository owner know, in this case, it would be your project managers, saying, hey, my branch is good to go. I'm ready for the world to see this. The code is done. It's working. Let's merge it into main. So I'm going to prepare and make a pull request. All right, so I'm going to name my name my pull request. Let's say final presentation. Let's say that's all I needed. And I'm going to just leave a little comment saying updated my readme.md to the point where I'm okay with the world seeing it. Awesome. I'm going to create my pull request. But now here's the issue. This branch has conflicts that must be resolved. And it tells you pretty clearly what the conflicting files are. It's kind of a big lecture, so I won't pause and ask for people to figure it out. But if you have figured out what the conflict is, that's great. That's really good to be able to anticipate conflicts. But essentially what the issue is that, as I did before, when Rachel pushed to main in her line saying testing to see if this updated, I didn't pull that to my DhruvKS2 branch. Instead, I just added the thing on my line saying I'm ready for the world to see this testing, but I don't actually have Rachel's update of testing to see if this updated. So if I click on this, right, the web editor, I can see clearly here, okay, so I have all of this testing this line. Now I'm ready for the world to see this, but this is what the main branch is. Now, if this wasn't here, just testing to see if this updated, it would merge great, right? This line is the same, just this line was updated and everything before this period is the same. So all it's going to do is append this stuff. But in my branch through KS2, as you can see here, I don't have the testing to see if this updated. So what does that mean? It essentially creates a merge conflict. It means that I can't just press a button and have my two branches merged together. I need to fix something on my DhruvKS2 branch before it slots back in perfectly into main. So there's multiple ways you can do that. VS Code has its own built-in things. You can use the web editor here on GitHub, but I'm essentially just going to manually paste it in here. Okay, so now this should be good to go. Hopefully there's no other issues. So I'm going to git add, git commit, fix merge conflicts, and then git push origin DhruvKS2. Everything was successful, great. So I'm going to come over here and I'm going to look at my pull request. And my pull request is essentially just my branch. So if I come to my branch over here, you can see, okay, awesome. I have Rachel's stuff here and I also have my stuff here. Awesome. I'm going to go to my pull request. I named it final presentation. And let's see. Okay, still have conflicts. All right. Oh, so the conflict is essentially these two differences. You can resolve the conflicts in multiple different ways, but for now, I'm just going to get rid of this because it is a little bit time consuming and I want to make sure we're respectful of everybody's time here. So I'm going to change that. And let's see, sorry, the videos are blocking a bit of the code there. So let's see. Okay, perfect. I've updated this and I'll add my ready for the world to see this. I'm going to mark this as resolved. All right, and I'm going to commit this merge. All right, and as you can see here, there are no more merge conflicts. These branches can slot in perfectly with each other. There's no reason that they can't. All we need is you can require approval. We're not going to really enforce this. We do ask that you wait for your project managers to comment and say, hey, looks good to go. You should not actually be merging the branches in yourself. But for the demo purposes, let's say my project manager looked over it and said, hey, looks great, ready to go. I've merged my pull request. I confirm my merge. All right, pull request successfully merged and closed. So what exactly does that mean, right? That means if I go to code and I come over here to my main branch, that I can officially see all of the changes. So I see the changes that I made on my local machine, and I also see the changes that Rachel had made before that I resolved with my merge conflict. So now this is ready to go. I'm ready to show it to the world. My friends can clone it and they can pull from it and get the most up-to-date versions, and everything is all good to go. So one thing to note is, let's say I go back to my main branch on my local machine, right? It kind of spoils the surprise here a little bit, but it tells you your branch is behind origin main by one commit. So what this means is essentially, this is what I have in my branch, on my main branch, because it's been a while since I've pulled from my main branch and there's been a lot of activity. So I'm actually missing both of those little, things that have been appended to the end of these two lines. So way to fix that, very easy. Git pull, everything was great. One file changed, that was readme.md. I come over here and I can see those changes. Okay, I think that is pretty much it. Hopefully we gave you guys a good overview of, all the steps that Rachel kind of went through here, creating the repository. Your product manager is going to be taking care of that for you, but it's pretty simple. You just click the new button, give it a name. We showed you guys how to push to the repository. We showed you guys how to clone. We showed you guys how to create a branch, how to push to that branch, and also how to merge the branches, and then how to pull to make sure that you have the latest changes after the merge. You can use this as your pretty straightforward guide. Usually you're going to do git add dot just to add all of your files. But as I said before, if there are specific files you want to work on or specific files you want to keep working on without pushing git for some reason, you can specify which files you want to put in the staging area. So as opposed to the dot, just do git add readme.md. And then your git commit and your git push origin and then the branch name. And then pulling as simple as git pull. All right, I'm going to stop my share here. Thank you guys so much. And yeah, I think we're going to have a few questions now, but if you guys don't have any questions, feel free to log off. If you do have questions, feel free to stay back. But yeah, I'm going to keep recording just so those of you guys who are watching the video online later can get the answers. All right. Yeah, project kickoff is at 6 p.m. on September 11th. Let's see. If I want to modify a file, so if user A wants to modify a file that user B is working on and B agrees to that, would it be okay for user A to directly modify without creating a branch? Yes, that is okay, but typically branching is just kind of the accepted practice. That's what you want to use. Even if user B kind of agrees, you usually create a branch just to make sure that if you do have any bugs in your code, so let's say, user B says, hey, I'd like you to edit this, you're good to go. But you accidentally make a typo, you forget a semicolon somewhere, you mess up a pointer, and you push it straight to main, that is going to cause a lot of issues. So usually you just create a separate branch anyway, wait for somebody to review it to make sure, hey, this looks good, I don't see any bugs, and then you guys all currently agree, and then you push it to main. So you can just directly push, but creating branches is also a safeguard against, faulty code or buggy code. It enforces a level of actual review from your peers.
Okay. Oh, do you have any? Okay, I'm just gonna read one of the messages that we just got. Should I use branches even when I'm the only one working on the project? Um, I would recommend it. I think it's a good practice, especially because when you like do go into industry or work on like larger projects, generally you will be making a lot of branches. And so one thing that creating branches is helpful for is if you're working on like a lot of different features. So for example, let's say you want to create feature A, feature B, and you kind of want to like work on them simultaneously, or they just like take a long time. And so you're not necessarily finishing one feature before you move on to the next one. And so like having that feature branch allows you to work on things in isolation without like affecting the rest of your code and breaking things.
Okay. In terms of GitHub workflows, I'm trying to recall. I think I did forget to go over the Kanban board. That's something we'll go over at a later date. But yeah, we are going to be using GitHub projects with the issues. So that is kind of the only other part of GitHub that we're going to be using beyond the actual repository itself. We're going to have, your Scrum boards where your project managers will be assigning issues that you guys will be dragging between, to do, completed, reviewed, merged, and things like that. But of course, we do actually have a lot of other videos about GitHub on our YouTube channel. So if they are covered, I'm not too sure if GitHub Workflows is covered there, but you can review those and hopefully you'll have all your questions answered. All right. To fix the merge conflicts, you added the line of code you were missing to your branch. What if you wanted to remove the code from the main branch? So let's see. If you wanted to remove the code from the main branch, how would you reserve the merge conflict? Okay, so Essentially, what that would look like is you're merging stuff into main, right? So if you want to change something on main directly, such as removing that code, you would have to push to main and get rid of it. But when I have branch A and I'm merging branch B into branch A, it's like the burden is on branch B to match with branch A. So typically in the ideal world, there's nothing in your main branch that you want to get rid of because your main branch is filled only with your finalized code. So everything that has been reviewed is finalized and is good to go is in your main branch. And then anything you want to add onto it, your next features are compatible because that is your core framework that's working. So if you wanted to remove the code from the main branch, you would typically just actually like go onto your main branch, edit it, and then push to main. No, you do not have to use Kotlin. For CS124 honors, we are very flexible. It's any tech stack you want to use. Sometimes students like to use Java or Kotlin just because it mirrors 124. Honestly, the most common thing we see is Python. But yeah, the tech stack is extremely open. You can work on whatever you'd like, use any tech stack you'd like, develop anything you'd like. So it's more up to you, your teammates, and your project manager what tech stack and what languages you're using. All right, awesome. I don't think there are any more questions, so I'm going to end the recording here. For those of y'all watching this later, thank you guys, and we will see you at Project Kickoff.